Hi, my name is Jeff, and I'm going to teach you how to add, subtract, multiply, and divide simple fractions. Fractions are made up of a numerator over the top number is called the numerator, and the bottom number is called the denominator. So what is a fraction? Well, fractions are just a part over a whole. And there are some different types of fractions, and we're going to talk about those. First, we're going to talk about what a proper fraction is. Well, a proper fraction is a part out of a whole. This is 1 out of 3. A fraction is also division. 1 divided by 3. 2 parts out of a whole that is broken up into 5 pieces. This is 3 parts taken out of a whole that is broken into 8 pieces. And this is 2 parts taken out of a piece or a whole that was broken into 3 pieces. And we can visualize this better if we make a circle. So I'm going to make a circle. Now this is the whole, and this whole at the bottom is broken into 3 pieces. So I'm going to break this into 3 evenly divided pieces. And this is 1 out of 3. So we can highlight this area right here. And this is a visual representation of 1/3. This one here, you can make another whole. And this hole is broken up into 5 pieces. So I'm just going to make some dots here. Alright, a little dot in the middle. And we're going to break this up into 5 evenly divided pieces. And 2 out of the 5, and we can shade these 2 pieces. You kind of get the idea. But basically a fraction is part out of a whole. And these are proper fractions, and the proper fraction has the part is less than the whole. You can take part of the whole. It's less, 1 is less than the 3. Okay? Another type of fraction is the whole fraction. And a whole fraction is simply the same number divided by itself. So 2 divided by 2 equals 1. 7 divided by 7 equals 1. 5 divided by 5 equals 1. 1 divided by 1 equals 1. 237 divided by 237 equals 1. You're taking 2 parts out of a whole that was divided into 2. So the bottom number here is the whole. You took a candy bar and you broke it in half, and then you took both halves. Here you broke the candy bar into 7 pieces, and you took all 7 pieces. You took a whole. That's why these are called whole fractions. Third one is an improper fraction. Well, the proper fractions up here had the numerator as less than the denominator. Well, the impropers, the numerators, are greater than the denominators. So a proper fraction's value is always less than 1. On an improper fraction, the value is always greater than 1. And on a whole fraction, it's always equal to 1. So the improper fractions, the value is always greater than 1. And because it's improper, we can actually convert those into what's called a mixed number. So we're going to go ahead and convert these impropers into a mixed number. We have 9 over 5. And again, a fraction is merely division. 9 divided by 5. Well, how many 5s go into 9? Well, just 1. And what's the remainder? 4. Because 1 times 5 is 5. Plus 4 equals 9. So 1 5 goes into 9. We have 4 left over, and then we keep the same denominator. So 9/5 is equivalent to 1 4/5. Let's try another one. 4/3. How many times does 3 fit into 4? Well, once, with 1 left over, and then we bring that denominator over. So 4/3 is equivalent to 1 1/3. Let's try 11/7. Well, again, only 1 7 fits into 11, and there's 4 left over, and then we bring the 7 over. So 11/7 is equivalent to 1 4/7. And then the last one, only 1 2 fits into 3 with 1 left over. It's 1 1/2. So 3/2 is equivalent to 1 1/2. Now you'll notice because these are impropers, their values are always greater than 1. And we've turned these impropers into mixed numbers. Now, I've also made some other mixed numbers here, and we're going to convert these mixed numbers back into impropers. And the way you do that is you take the whole number, you multiply it by the denominator. So 2 times 3 is 6, and then you add the numerator. So 2 times 3 is 6, plus 1 is 7, and then we keep the denominator again. So 7/3 is equivalent to 2 1/3. You can do it again. 5 times 8 is 40, plus 3 is 43 over 8. 43 over 8 is an improper. It's greater than 1. It's equivalent to 5 3/8. Last one, 1 times 4 is 4, plus 3 is 7, and then we keep the denominator, 7/4. 7/4 is equivalent to 1 3/4. Well, the good news with multiplication is you don't need common denominators. In this case, we have them. That's fine. All you do with multiplication is you simply multiply straight across. So 3 times 1 is 3. 5 times 5 is 25. And that's it. Let's try this one. We're multiplying. We don't need common denominators. So what is 2 times 1? It's 2. 3 times 6? 18. Now what I notice is both of these are even numbers. Anytime you have even numbers, you can cut them in half. So what's half of 2? 1. What's half of 18? 9. Now I can show you another way. It's called cross simplification. You don't need to remember this, but it makes it easier to simplify. Is when you're multiplying two fractions, as you look at the diagonals, I see that 1 and 3, I can't do anything with those, but I see a 2 and 6. I know that 2 goes into 2 one time, and I know that 2 goes into 6 3 times. So if I were to multiply straight across going this direction, and I only go this direction because we've already gone this direction, 1 times 1 is 1, 3 times 3 is 9, and what we've done is we've already simplified it to 1/9. So we've done our simplification by cross simplifying versus getting an answer and then simplifying it. So if this is something you want to do, watch the diagonals. If it's not something you're comfortable with, simply go this route. Just be sure that if you can simplify it, you do. Here's another one. We're multiplying. We don't need common denominators. We simply multiply straight across 2 times 1 is 2. 2 times 3 is 6. Again, these are both even numbers. I can cut them in half. Now, if I were looking at my diagonals, I know that 2 goes into itself once. And I'd have 1 times 1 and 1 times 3. And you can see that we get the exact same end result. Our last one, we're multiplying. We don't need common denominators. We simply multiply straight across. But before we do, let's check our diagonals. I can't do anything with these, and I cannot do anything with these. 1 goes into 1 once, 1 goes into 8, so that doesn't change. 2 and 3, I can't do anything with, so I'm just going to multiply straight across, and I know my answer will already be simplified. 3 times 1 is 3. 2 times 8, 16. 3/16. That is my answer. Like multiplication, you do not need common denominators. So one thing about division, if I said, what is 2 divided by 2? Well, 2 divided by 2 is the same as 2 divided by 2, which is the same as 1. But I can also say these are really like fractions, right? 2 over 1 divided by 2 over 1. Well, 2 divided by 2, you said was 1, and 1 divided by 1 would be 1, so that also equals 1. But the interesting thing about division of fractions is you can keep, change, flip. We're going to keep this 2 over 1. We're going to change this from division to multiplication, and we're going to flip this. Two times 1 is 2. 1 times 2 is 2. 2 divided by 2 is 1. We get the same answer. In the same way that 2 divided by 2 is the same as 2 times 1/2. What's half of 2? Well, it's 1. Okay? So why I do that? Well, because it helps explain why we keep, change, flip when we're dividing fractions. So here's some fractions. We're going to keep the first number. Must stay the same. 3/5. And instead of division, we're going to change it to multiplication. And then we're going to take the next number and we're going to flip it. So we can simply multiply straight across and simplify, or we can check our diagonals first. And I notice I have a 5 and a 5. Well, I can cross those out, make those 1s, because 5 goes into 5 once, 5 goes into 5 once, and then I have 1 times 3 equals 3, and 1 times 1 equals 1. And 3 over 1 is just a fancy way of saying 3. If we didn't do that first, if we did 3/5 times 5 over 1, and we simply multiplied straight across, we'd have 15 over 5. Now I would notice that both these numbers end in 5, so they're divisible by 5. How many 5s go into 15? 3. How many 5s go into 5? 1. And we end up with the same answer. So if this is comfortable, by all means do it. If you're not comfortable with it, do it this way. Let's try this one. 2/3, keep, change, and flip. Now I'm going to go ahead and do the cross simplification because I see my 6 and my 3. I know that 3 goes into itself once and it goes into 6 2 times. So 2 times 2 is 4. 1 times 1 is 1. And again, 4 over 1 is just a fancy way of saying 4. And if we didn't do it that way, if we did 2/3 times 6 over 1, and we simply multiplied straight across, 2 times 6 is 12. 3 times 1 is 3. And we can look at this as 12 divided by 3, which is 4. Or how many times does 3 go into 12, which is the same thing as 12 divided by 3, which is 4. We can also say how many 3's go into 12? 4. How many 3's go into 3? 1. Either way, we end up with the same answer. Let's try this again. 2/3, we're going to rewrite it, keep, we're going to change, and we're going to flip. Now in this case, I look at my diagonals. I know that my answer will already be simplified because I can't do anything either way. So 2 times 2 is 4. 1 times 3 is 3. 4/3. It's an improper. If my answers are improper fractions, then I don't have to do anything else. If my answers are in mixed numbers, I need to convert this to a mixed number to find the right answer. Well, how many 3's go into 4? 1 3 with 1 left over, and then we bring the denominator. So either one of those answers is correct. Our last one, keep, change, and flip. I notice again that I have a 2 and an 8. I know 2 fits into 8. 2 fits into itself once, fits into 8 4 times. 1 times 3 is 3. 1 times 4 is 4. So 3/8 divided by 1/2 equals 3/4. Again, if I didn't do it that way, if I did not use cross simplification, I simply multiplied straight across, I'd have 2 times 3 is 6. 1 times 8 is 8. But I would notice that both these numbers are even, therefore I can cut them both in half. What's half of 6? 3. What's half of 8? 4. And I get the same answer. So let's add some fractions that have like denominators. In order to add and subtract fractions, you must have a like or common denominator. The denominator stays the same, and we simply add the top numbers. So 3/5 plus 1/5 equals 4/5, and that's a proper fraction. Let's try another. Well, in this case, the denominators are not like. So the first thing we do is we say, will the little number fit into the big number evenly? In this case, 3 does fit into 6. So is there something we can do to this number to give it the same denominator as this fraction here. Well, what would we have to do to this 3 to make it a 6? We would multiply it by 2. Now, if we multiplied this fraction by 2, we would be changing its value. We don't want to do that, because the question is, what is 2/3 plus 1/6, not a different number plus 1/6. So in order to keep the fraction value the same, we're going to multiply this fraction by the value of 1. Anytime you multiply a number by 1, it doesn't change the value. But in this case, we're going to multiply it by 2/2, which is a whole fraction. And this fraction equals 1. So we're multiplying this fraction by the value of 1. So we're going to change what it looks like, but we're not going to change its value. So now we have 2 times 2, which is 4. And we have 2 times 3, which is 6. And then we're going to have the addition. And we didn't have to touch this one because we have like denominators now. So now when we add, we keep the denominators the same, and we simply add the top numbers. 4 plus 1 is 5. So 2/3 plus 1/6 equals 5/6. Let's try another one. Here we have unlike denominators again. Now, will the small number fit into the big number evenly? In this case, it doesn't. Now, you could try to find the least common denominator. So in this case, what I recommend is you simply multiply the denominators together. So on this side, we're going to multiply this 3 times 2, and this 2 times 3. But again, we don't want to change the value, so we're going to make this a value of 1, and we're going to make this a value of 1. So we've multiplied both sides by the value of 1. We have not changed any of the values. We're only changing what the fraction looks like. So this 2 times 2 is 4. And this 2 times 3 is 6. Plus 1 times 3 is 3. 2 times 3 is 6. And this is what's known as equivalent fractions. 2/3 is equivalent to 4/6. Had a whole that was broken in half and you took one of those pieces, you'd be eating 1/2. If that same whole was cut into 6 evenly cut pieces and you took 3 of those, you'd be eating half still. So these fractions are the same value. These fractions are the same value, but the denominators are the same, so we can now add them. The 6's stay the same. 4 plus 3 is 7. So 7/6. Now this is an improper, and we can leave it like that, or we can also convert it to a mixed number. How many 6's go into 7? Well, 1, with 1 left over, and then we bring the 6 over. This isn't completely necessary, but if your answers are all mixed numbers on a test, you're going to want to go ahead and convert it to a mixed number. And let's try one more. Let's see, denominators are different. Will the little one fit into the big number evenly? In this case, yes. So what do we need to multiply this 2 by to get it to equal 8? Well, 4. And again, we're going to multiply the top number by 4 as well, so we don't change the value. And 4 divided by 4 is a whole fraction, equals 1. So we have 3/8 on this side. We didn't have to touch it. Plus 1 times 4 is 4. 2 times 4 is 8. And again, 1/2 is the same value as 4 out of 8. Keep the same denominators the same. 3 plus 4 is 7. And so the answer 3/8 plus 1/2 is 7/8. Subtraction is pretty much the same. The only difference is you're subtracting. The denominators need to stay the same again. In this case, the denominators are the same, so we just bring it over. And then what's 3 minus 1 is 2. So 3/5 minus 1/5 equals 2/5. Pretty simple. Another subtraction, but the denominators are different. So the first thing we do, will the little number go into the big number evenly? In this case, it will. What do we multiply the 3 by to make it a 6? Well, we can multiply it by 2. And if we do the bottom by 2, we need to do the top by 2. Again, this is a whole number, whole fraction, and it equals 1. So 2 times 2 is 4. 2 times 3 is 6. Minus 1/6. We're going to keep the denominators the same. 4 minus 1 is 3. Now we can simplify this. What number goes into both of these numbers evenly? Well, 3 goes into 3 one time, and 3 goes into 6 2 times. So 3 over 6 is actually equivalent to 1 over 2. So the answer, 2/3 minus 1/6, is simply 1/2. Let's try this one. We need the same denominators because we're adding or subtracting, but these are different. Will the little number fit into the big number evenly? No. So the easiest way is to simply multiply them together. So this side is going to be multiplied by 2. And what I do to the bottom, I do to the top. And this side is going to be multiplied by 3. What I do to the bottom, I do to the top. So 2 times 2 is 4. 2 times 3 is 6. Minus 2 times 3. It better be 6. That's the whole reason we did it, to get the same denominator. So I'm just going to carry that over. And 1 times 3 is 3. And then it's just 4 minus 3 is 1. So 2/3 minus 1/2 equals 1/6. Our last one, we're subtracting. The denominators are different. Will the little number fit into the big number evenly? In this case, yes. What can we multiply this 2 by to make it 8? Well, 4. And if we do the bottom, we're going to do the top. So let's go ahead and make our fraction at the bottom. We have 4 times 1, which is 4. 4 times 2, which is 8. We just bring this one over. And we're going to carry the denominator. So what's 4 minus 3 is 1. So 1/2 minus 3/8 equals 1/8. So I hope this has been a helpful lesson on adding, subtracting, multiplying, dividing simple fractions. Thank you for your time.